Now for this lab, we're going to be taking resistors, finding out what their resistance is, and then calculating such things as current and voltage and things like that. So the first thing we have to learn is to identify what the resistance is. So you may have to reference that little resistance chart that's in the photograph. This particular resistor is brown, black, black, gold. Now the gold part tells us how accurate it is. And the brown, black, black tells us the number. So let's look at this as an example. So brown means it's a 1, and that tells us the first digit. Brown, black tells us what the second digit is. So 1 and a 0 makes a what? A 10 so far. And then the third color tells us how many zeros follow that. So if you have a 1, a 0, followed by another black that's 0 zeros, so what's 10 plus 0 zeros? It's 10. So the resistance of this resistor is 10. So we're going to put in here the rated, and then we're going to put in here the actual. So the rated is 10 ohms. Now the reason for the gold is that we know that it's tough to make things absolutely perfect, so that is how carefully it's made, such that it's gold is a very good tolerance within plus or minus 5%. So it could be anywhere from 9.5 to 10.5. So the next thing we're going to do is we're going to actually measure it. To do so, we're just going to put it in here just to hold it. That's all it's doing for us. And then we're going to take this multimeter, it's called, and we're going to turn it on. And right now it reads nothing. And we're going to put this on the resistor and see what it actually says. So it's 10.3. So that's what we're going to write down here on our little sheet, is 10.3 ohms. And the next thing we're going to do for each circuit is we're going to find what the current is. Now in order to measure current, you have to be in series with the object. So we've got the battery wired up, connected to one side of the battery, and then I'm going to skip a spot here and put this over here so that I can put the multimeter in between. Now one of the things that we have to do for the multimeter is, you see, if we want to measure amps, we have to switch this guy over to here and change the dial. So this is a very popular thing to forget, and I might do it during this video. So we have to switch it over here to the yellow side, and then I'm going to move it over here and turn it on. So it's a range, and we're not sure, we're just measuring. And we get 116 milliamps. 116 milliamps. 116 milliamps. Now we've got to find the voltage that this resistor is experiencing. So here we have this in the circuit. We'll connect this here in just a minute. In the meantime, I'm going to get my multimeter ready. It's on ohms, so I need to change it to volts. So that's 0 to 20. And let's see what it says when we connect it to the battery. We get 1.34 volts. 1.34. As some of you will notice, it says negative. I can switch that back and forth. It's just saying which direction. That's negative. If I go this way, it's positive. So the multimeter knows which way the electricity is going. So the voltage is 1.34 volts. Now, we can do the calculation and see what is 1.34 volts divided by, we're going to use the actual because that's what we're measuring, 10.3 ohms. So 1.34 divided by 10.3 is 0.130. Now if I were to convert to milliamps, that would be moving it over three places, 1, 2, 3, which would be 130 milliamps. 130 milliamps. All right. Okay, I should also point out that 130 and 116 are not the same, but we're kind of close. So ideally, we'd like to get that number the same, but as it is in science, a lot of times we get our data just a little bit off. All right, so we're going to do another one here, and we're going to bring in this resistor. This resistor, you may want to write down these colors with some kind of a symbol, but I'll try to bring it really close here for you. So this one is orange, orange, brown, gold. So you might write here orange, orange, brown, and the gold doesn't really matter too much. I'm going to put this in my little circuit, getting ready. Now, according to our little chart, what is he? So according to our chart, orange is 3, another orange is 3, and then a brown tells us how many zeros after that. So that's a 3, and another 3, and 1 0 after that. Brown is a 1, so that means there's 1 0 after it. So our resistance should be 330 ohms. Well, let's find out what our multimeter says. Let's put this on resistance. I'm anticipating around 300, so I got to be over 2,000 here, over 200. So I'm going to put it on here and see what we got. You can't see that. So we got 329. That's kind of close to 330. So let's write down our actual was 330. Now our current, we're going to have to switch our plugs and switch it over to here. Let's put it such that we have to have it in series and see what it says. .2. 4.2 milliamps. That's what it says. 4.2 milliamps. All right, so let's finish up this row. We know that the voltage is 3.4 volts because the battery is the same battery. So we're going to take 1.34 volts and divide it by 330. We'll go 329 and put that in the calculator. 1.34 divided by 330, and you get that number, which if we move it over three places, that comes out to be 4.1 milliamps. Well, that's pretty close to what we measured. We're doing good. All right, let's keep going. Our next resistor, try to bring it up close to you, but it is red, red, yellow. Red, red, yellow. So you might want to write down here on the side, red, red, yellow. And then pause the video on this as long as you need it, so you can read the code there for red, red, yellow, and figure out what is the resistance, the rating on it. I'm going to let you figure that out. I'm going to go ahead and measure it, so it might be a little different than what it's rated, but it should be somewhat close. That way you can know if you're reading it right. I'll move this here. And we're going to go to resistance. And the resistance is 217,000 ohms. So this is a big resistor. 217,000 ohms. 217,000 ohms. So now let's figure out the current that's in here. So I gotta switch this to here, and we're gonna go so the amperage there is 6 microamps. 6 microamps. I was making a mistake earlier of putting it across here. Well, that would be for voltage. You have to be in series to do current, and so it's 0.6 microamps. So let's see how that comes out on a calculation. So 0.6, no, it was 6 microamps. Micro is that funny mu looking thing, which is times 10 to the negative 6. We still have 1.34 volts. So we're going to take 1.34 divided by 217,000 ohms, and let's see what that gets us. 1.34 divided by 217,000. 6 times 10 to the negative 6. Hey! We got basically 6.2 microamps. All right. Let's keep rolling here. Let's do the next one. And our next one is red, red, black. Red, red, black. So I'll let you figure that out and figure out what goes there. Look at the chart. Here you can look at it and pause your video if you want. And I'm going to put that in there. I'm going to be lazy and switching. I'm going to do the current first. So we've got 58.8 milliamps. So what was that? That was 58.8 milliamps, 1.34 volts. Let's find the resistance by putting this back over. And I should be down here. And we have 22.2. That's 2.2 amps. I'm going to let you do the calculation here to find the current and see if that calculation matches. And we're going to do one more. And this one is brown, green, black. Brown, green, black. All right, so brown, green, black. Here's the chart again. So you can pause your video and write down what its calculated value is. And then, so it's brown, green, black. So let's go ahead and measure that. We got 15.1. And 1.34 volts again. And the current, we have to switch back to here and go from here to here. Let's see, you can't see that. Oh, I gotta switch. Got 84.4. 84.4 milliamps. I'm gonna let you calculate that, see how that compares, how the calculation compares to our measurements. All right, so the last part of this lab, you're gonna tell us how does the data for amps, that is this column, how does this column compare to the voltage divided by the resistance? And you'll notice that the numbers are pretty close. And this is why we have the relationship that V, voltage, equals IR. Voltage equals current. And so when you rearrange this to get I by itself, the R comes over here and you get V over R equals I. And so this should compare to this to support Ohm's law. All right, that's it.